Okay, so let's check out another instruction that we're going to look at, and these are the last two: the jump instruction and the label instruction. So the jump instruction essentially lets the program jump from whatever line it's on to whatever label it's attached to right here, to right here. That's if the jump instruction is enabled. Well, that'll give us a couple interesting little effects that we can do. One of the big reasons we do this is so that we can skip portions of the program that are not necessary. If we want to skip an entire portion of a program, that might increase the scan time or decrease the scan time of the program. It lets us use what resources we have more efficiently, and other interesting effects hopefully we'll show here a little bit later. Okay, so let's go over what this program does a little bit. You will see that push button 1 will be connected to a jump instruction, the JMP. The next line, there will be push button 2, and that's connected to just a normal old output. And then the next line, there is a label instruction, and it is also addressed to the exact same address. And on this line, it will end with another output instruction. Okay, let's talk a little bit about this jump instructions address for a moment. So we're using a new address here, Q2.0. So what Q is a data table that is just for jump instructions. It's saying that this and label instructions, since they use the same addresses. So it's just for jump and label instructions, not for anything else. The 2 here is not like these where it's data table 2. It's actually saying that this is ladder 2. Ladder 2 is our main program, and that is what our 2 here is. So we're saying that this is on our label instruction on ladder 2. And 0 is a unique identifier. Just like with most things, we can have a whole lot of different things. We can have up to 255 of them if we want to, and we can have them all throughout one of these programs. That would be a lot of jump instructions, but we have enough to do that. So let's try this thing out. And I implore you to think about what this thing might do. So I'm going to not activate this rung, and I'm going to actually activate PB2 to show that this is normally working. Alright, I'm going to activate PB2, and PB2 is on, right? And it's activated our output. Simple stuff. We're used to it. We've seen it a lot. I'm going to disactivate this bit now. Alright, now let's activate our jump instruction. So our jump instruction should now jump from this line to this line, because we've labeled it the exact same thing. Alright, let's see what happens. I'm going to try to toggle this. Push PB2. Alright, PB2 is activated, and our output is not activated, right? Of course it's not. It's because even though we've activated PB2, this line is never being read right here. This line is not even being read. The jump instruction completely goes over this line. So if we had 100 things in here, it would completely go over everything and go to this label. Alright, so I'm going to turn off the jump bit. Alright, let's turn this PB2 off now. Okay. Or, well, I could have kept it on. But let's turn it back on. Doop. Alright, look. So if you'd noticed, I was being a little bit too quick there, but when I disabled this jump instruction, this started working, right? As soon as I let it go, because I was holding down PB2, I was flipping the switch of PB2, right? Well, what would happen now if I jump it? Let's see. Boop. Wait a moment. Everything down here is still on, but we're jumping it, right? What if I disable this PB2? Ah, our output is still on. Our output is still on. That's weird, right? That is because this line controls if this output is on or off, right? It controls if this output is on or off. It's actually writing something into this output. If we look here, our output is still in 1. Still true. So that's something to understand. is that if you're using a jump instruction and this line turns this output off when it turns off, then by jumping over it, this will get stuck in its output on position and it will not change back. Okay, so let's take a gander at a more complicated version. Okay, so our Pt.1 controls our jump instruction, and that jump instruction is connected to this label instruction down here. Furthermore, inside of this box between these two things, we have an input that I didn't name, and it's connected to a timer on delay, and we have a retentive timer in the box too. Now you'll notice that this retentive timer has no activating instruction. It can do that. It'll just mean that this retentive timer will start as soon as the program is running and keep running. And you see I've set the presets to very high numbers. Down here, past the label in the timer timing instruction, this will turn on an output if both of these are true. And the label instruction is always true. So this is connected to an output, and when the timer of this is running, this will become true. And when the timer of this one, of this retentive timer right here, is running, this output will become true. Okay, let's run this bad boy and see what it does. Alright, fairly normal stuff. Our retentive timer is timing because it has a true line. I'm actually going to turn this bit on and start our timer on delay as well. And we look down here, and both of our timer timing bits are of course flipped because the timers are timing. Alright. So let's see what happens if I toggle my bit for my jump. I'm gonna go ahead and jump from here to here. Let's see what happens. Okay, I'm jumping. I'm jumping from here to here now. Well, first you'll notice our accumulated values are not increasing anymore, even in the retentive. Even though there is no bits here, this retentive is still not increasing, and neither is this timer on delay. So one of the things about a jump is it disables the accumulation of these timers. These timers will not accumulate while they're being jumped over. But you'll notice that the timer timing is still enabled. It's still enabled, right? That's because whatever bit that enabled these timer timing is not being disabled. So that timer timing is still 1, and this will still be closed right here. And same thing for right here. And even if I flip this bit right here for this timer, it doesn't change anything, right? I'll change it back. Ah, look at this. Did you notice what happened to my accumulated value? Let's do that again. I'm going to 115, 1 1000, 2 1000, 3 1000, 4 1000, 5 1000. See what happens. Hey, my retentive timer, even though it didn't keep up, it wasn't timing, the accumulated value was not increasing, while the jump instruction, it did fix itself, right? So when this turns back on, it just catches back up to wherever it was, even though it wasn't timing while it was jumped over. It still caught up to itself. That's an interesting feature of retentive time.